Hey everyone, I'm Raviteja from KL University, Hyderabad. Today we are going to discuss about single and multi-layer perceptron. So let's start. So before talking about single and multi-layer perceptron, let's first know about what exactly is perceptron. So in biological terms, we can say perceptron as a single neuron. A, perce- a single neuron in artificial intelligence terminology is known as a perceptron. So, a perceptron is a neural network unit that contains or does certain computations to detect features or business intelligence in the input data. So, it's a single neuron that has adjustable weights. So, when we map this to our biological or our surroundings, we can say a neuron is responsible for every single task that we do. Whether if we like put our hand on a vessel, our neuron gets activated and just says like, yeah, remove that hand, else you will be burned out. So in the same way, a perceptron is responsible to make take certain decisions in a neural network. It has inputs and based upon that it takes an action. So using activation functions we take certain action in certain direction. So in general we have two types of perceptron, single and multi-layer perceptrons. So what is single layer perceptron? Single layer perceptrons can learn only linear separable data or linearly separable patterns. And multi-layer perceptron learning can we can say that they can learn non-linear separable data, and it has two or more layers so that it can achieve greater processing power. So let's in general, a perceptron contains four parts. That those are input layer, and input values, weights and bias, net sum, and activation function. So inputs are the thing that the perceptron takes with respect to the weights. So for perceptron, a single perceptron computes itself by using weights, inputs, and bias, and then it does the net sum, and depending on some activation function that it uses, it takes certain decisions. So coming forward, let's start to learn about single layer perceptron. So single layer perceptron has just two layers, which is input and output. So we might be wondering, why is it named as single layer perceptron when it has two layers? But the thing is, like, we just have one layer where the computation takes place. So that's the reason why we name this model as a single layer perceptron. So it can solve only linearly separable problems, and it doesn't have any uh, what we say hidden layers. So we'll talk about hidden layers in the next coming slide, where we learn about multi-layer perceptrons. So we can talk what we might be having, what is a linearly separable data. So you can say like we are having a graph where, let's say, the x and y axis represents certain inputs, and with respect to that we have got certain outputs. So let's say I'm labeling it somewhere here for some data, and then I'm labeling somewhere around here for some other data. So this is something that I have. So I can draw a line between those, like these are linearly separated, and I can say that above this line it has an output of type A, and below this line I am having an output of type B. So as we are separating these two data in with a single line, we are saying this as a linearly separable problem. So now let's start about learning what is multi-layer perceptron learning. So multi-layer perceptron learning has a greater computational power as it solves non-linear problems. So, what is as we have learned about the drawback of a linear or single layer perceptron, as it can solve only the linearly separable data. It can solve only the data which is present on one side and which is present on the other. It cannot solve if a model has the outputs. Let's say I'm having outputs somewhere around here, and I'm also having another output which is surrounded, or and then and I can say that another output is also, this is the same output as it is of inner. I'm surrounding with this, and then so yeah. So this is a difficult problem where a neural network gets trained. So this takes greater computational power, and it's difficult for a machine to analyze what is based on inputs and outputs, what can be the output. So multi-layer perceptron can solve this type of problems where it requires uh, greater computational power. So I can say in general a multi-layer perceptron has just three layers. One is the input layer where we get all the inputs from, and one is the hidden layer. I'll talk about hidden layer now in next. And then we are having one output layer. So we know hidden layer, and we know input layer and output layer. So what is this hidden layer? It's interesting, right? So hidden layer is nothing but these are the hidden computational layers where, so this might be many, it has many neurons, many layers, these are connected, and this can be many actually. So this is why this layer is known as hidden layer. Like we can't define how many layers, like the user, uh, so the one who wants to use this type of network decides the number of layer presents in the hidden layer. So in that terminology we can say uh, this as a hidden layer, because this is hidden for everyone. Like anyone can decide how many layers one can choose. It's not up to account. Like we can use only these many layers. We can use n number of layers to have more uh, what we say, to have more computational power. So this is quite much about multi-layer perceptron. So in the next slide, we'll take an example and know how we are using this in a day-to-day scenarios. We'll take an example of logic gates and try to solve them. So now we are gonna learn how this single perceptron layer and multi-perceptron layer actually affects. So here is the logic gates that we are having. So this is an AND gate, OR gate, and an XOR gate. So as we know, an AND gate, for every right output we get, like for every value S and S we get the value as S, and for every thing like 1 0 and 0 1 and 0 0 we get all the zeros. So for this type of data we can use a single layer perceptron, as we can separate this part with this line, and we can say, so whatever the like, okay, I might be drawing other, so I can say like here, depending on the output, this is our graph now. So here if I draw a line, this got separated, right? The above I'm having 1 and below I'm having all zeros, so I can separate this data with a single line. So even with the OR case, and we also know the OR table, so only for 0 0 we'll be getting the value as 0, right? So if we plot this in a graph, so I can I can draw a line here, and I can say above this line I'm having all ones, and above below this line I'm having all zeros. So let's try doing this on XOR gate. So these are the outputs. For one I'll be getting 0, and for 0 I'll be getting 0, and for the rest all I'll be getting the value output as 1. So let's try to make this as a linear. Let's see, can we make it? So how can we draw a line? Can we draw it in this way? No, because one left here. Okay, can we draw in this way? No. So this is why we introduce multi-layer perceptron. So it can't be separated by just a single line. It requires one more line, or like we can say, we can draw this line and we can say in between these two I'm having one data, and above other than that I'm having other data. So this can be separated with two lines. So this is an example, this is a good example where we can say for this a single perceptron layer network cannot solve a problem where it used to solve here, but now this that single perceptron layer got failed in this case. So for this we have used multi-layer perceptron learning to achieve this part. So here is one more example where single layer perceptron solves linearly separable, so we can say it is drawn here, and multi-layer perceptron can draw something if it has more hidden layers. It can train certain things, and it can have this line here and here, so it might go, it may vary on data. It learns, right? We can't say how it goes on. It learns upon depending upon the input values and trains itself and gives us the accurate results. And in this case we can say about these lines we are having one type of data, and below this we are having one type of data. So this is a good example where we can get to know about how the single perceptron layer learning and multi perceptron layer learning helps in day-to-day scenarios. So yeah, so we have covered a lot and we have learned about single and multi-layer perceptron. Hope that helps you. So we'll meet soon. Yeah, thank you.